So hello everyone again. This is lecture 4 part 2 of your semiconductor electronics material devices and simple circuits. So in the previous part of this lecture only we have started with the PN junction concept. So let's begin our discussion directly from there only. Let's not waste any time. So I am Sameer Lavankar. Let's begin our discussion. So right now we are on the fifth concept, that is PN junction. Let us understand this. In the previous concepts of this lecture series, we have completed with the introduction, classification of metals, conductors and semiconductors, intrinsic semiconductors, extrinsic semiconductors, and right now we are on the PN junction. So let us understand PN junction very clearly so that we can understand the future concepts. Okay. So right now in the last part we have understood that okay, so for conduction, for the formation of a PN junction, what we did was there was a thin P type semiconductor silicon wafer. So let us say this is your P type wafer. Okay, so P type silicon wafer, and by adding precisely a small quantity of pentavalent impurity. So what we basically did, we added a +5 impurity into it. So when we added a +5 pentavalent impurity, part of the PSI wafer can be converted into an NSI. So what happened basically, that a part of this converted into an NSI and a part of this was a PSI only. So that lead to a N here, a P here, and a metallurgical junction here. Okay. So that is only being written in this line here, that the wafer now contains a P region and an N region and a metallurgical junction between the P and N region. Okay. Two important processes occur during the formation of a PN junction, that is called as diffusion and drift. Please understand these two lines, these two words very carefully, because these are the major points which we need to consider for this complete formation of a PN junction. Okay. So what they say, that there, okay, so there are two processes happening. What are these what are these processes? First is called as your diffusion and second is called as your drift. Let us understand each and everything which is written here. So we know that in an N-type semiconductor, please remember what is an N-type semiconductor. An N-type semiconductor is an extrinsic semiconductor which is in which we have added a pentavalent impurity. Okay. So we know that in an N-type semiconductor, the concentration of electrons, that is the number of electrons per unit volume, is more compared to the concentration of holes. We know this also, that the majority charge carriers in N-type semiconductor is basically electrons and the minority charge carriers in your N-type semiconductor is holes. Okay. Similarly, in a P-type semiconductor, what happens in a P-type semiconductor? What is a P-type semiconductor? A P-type semiconductor is a type of extrinsic semiconductor which are having more holes. So basically a trivalent impurity is added upon it, and therefore the majority charge carriers are holes and the minority charge carriers are electrons. So in a P-type semiconductor, the concentration of holes is more than the concentration of electrons. Fine. That being said, now during the formation of a PN junction and due to the concentration gradient across the P and N sides. Okay, so let me first explain what is this concentration gradient been explained here. Please understand this very clearly so that you can understand PN junction at a very greater detail. So let us say this is the wafer which was being talked about. Okay. Now what they are saying is, let us say this is your P type. Let us say this is your P type and let us say this is your N type. Fine. So if it is N type, then the amount which is available or visible more would be negative charges here, correct? Negative charges would be present in abundance in the N type semiconductor. Similarly, let us say I provide you holes by a single circle only. Okay. So let us say the amount, as the minority charge carriers will be electrons in the P type, therefore the amount of holes would be greater in P type, right? The amount of electrons will be very less. Here the amount of holes would be very less, correct? So as you can see clearly that there is a concentration gradient happening for both of these. As you can see that there is higher concentration of electrons here and a lower concentration of electrons here. So you can see that there is a higher concentration of electrons. So generally what we say, okay, so let's not go into technicality right now. And similarly there is a lower number of hole concentration here and a higher number of hole concentration here. So what we can say, there is a concentration gradient happening. Why? Because there is a difference in the concentration on the right hand side and left hand side. If we say it, if you are seeing from the front, so we can say that there is a difference in the concentration happening on the left hand side or right hand side, or let us say P type and N type. What is the concentration gradient of? Because of difference in the amount of concentration of electrons and holes. Okay. So let us read this line again. So during the formation of a p-n junction and due to the concentration gradient across the p and the n sides, holes diffuse from p type to n side. Okay, why the holes are diffusing from p side to n side? We always know that gradient is passed, or let us say not a gradient, put a movement is always from a higher gradient to a lower gradient. Okay. So movement is always from a higher gradient to a lower gradient. Due to this, what we can say, because the concentration of holes was very higher, the holes diffused from a p type to an n type. Holes diffuse from a p type to an n type, which is written here. Okay. And similarly, electrons diffuse from n type to p type. So basically the passage of these concentration carriers from any one direction to another, because of, or not one direction to another, from a higher concentration to another, is basically called as your diffusion. So therefore what we say, that the holes diffuse from the p type side to n type side, and similarly we say that the electrons diffuse from the n side to the p side. Okay. So this motion of charge carriers gives rise to diffusion current. Okay. So because diffusion is happening, therefore what we say, that the current, okay, so what is basically current? Why is a current produced? The current is produced due to the change in the concentration of charge carriers per unit time. So if it's if the motion is happening, if a motion is happening of, let's say, hole concentration or a electron concentration, there will be a current produced. This current is produced due to diffusion. What diffusion? Let us say the diffusion is of the hole carriers from positive to n side, p side to n side, or the electrons from the n side to the p side. Therefore it is called as diffusion current. Okay. So this motion of charge carriers gives rise to diffusion current across the junction. Fine. So we have completely understood what is this diffusion concept. Fine. Now let us understand more detailed. So when an electron diffuses from a n to p, okay, quite evident. Let me make the diagram again. So let us say this is your n type, and let us say this is your p type, correct? What would be happening here? Amount of negative charges will be very high. Here the amount of not the positive charges, holes would be very high. Okay. Here holes would be less, here electrons would be less. Okay. Now let us understand again. So what is written here? When an electron diffuses from n to p, so it is quite evident electron will diffuse from n to p only. So this will be a direction of diffuse of electrons. It leaves behind an ionized donor on the n side. Okay. So basically if the electrons are being removed, then it leaves an ionized donor, as in something which can donate. Okay. This ionized donor, so basically if a negative charge is being evolved from one position to another position, what we can say, so there can be two ways of saying this. One way of saying is that, okay, an electron or a negative charge is being moved from a n side to a p side, or in another way what we can say, that there was a generation of a positive charge on the n side. Okay. So there is two ways of saying this same concept, so they are just utilizing those concepts here only. Okay. So this ionized donor, so because there was a diffusing of the electron from the n side to the p side, what we say, that it leaves behind an ionized donor on n side. This ionized donor, positive charge, is immobile, as it is bonded to the surrounding atoms. Okay. Immobile as in it cannot be moved. Okay. So why it cannot be moved? Because it is surrounded, or it is bonded to the surrounding atoms. Okay. Let's understand more. Let us first understand more so that you can understand the crux where we are finally reaching. Okay, so we are trying to find a conclusion here. Let us go to the conclusion again, and then we can circle back if you have any doubt again. Okay, so as the electrons continue to diffuse from N to P, so there is a continuous diffusing of electrons happening because of change in concentration. A layer of positive charge or positive space charge region on end side of the junction is developed. Please understand this clearly. Okay, so therefore, because the electrons are keep on diffusing, you can see a positive charge layer is being created on the N side. As you can see, this was basically your complete N side. You can see there was a positive charge region is being created here. Okay, you can see from the diagram also that a positive charge region is being created here. Let me read this line again. So, as the electrons continue to diffuse from N to P, quite evident it will move from N to P only, a layer of positive charge. So, this is that layer of positive charge being talked about, a layer of positive charge or positive space charge region on N side of the junction is developed. Similarly, when a hole diffuses from P to N, let's change the scenario now. So now holes will move from the higher concentration, where it is having higher concentration, it is having higher concentration on the hole side. So it will move from P side to the N side. If it moves from P side to N side, so it is keep on moving like this. If it is moving, keeping on moving like this. So again, same concept can be divided into two types. One, it can be said that okay, so there was a positive charge here, it moved from this location to this location, that is from P type to N type. Or it can be said in another way that there was a generation of negative charge in this location. So that is why only there was no charge present here now. Okay, or no positive charge, or here positive charge being explained about. Okay. So as the holes continue to diffuse, okay, first of all let me read this again. So similarly, when a hole diffuses from P to N due to the concentration gradient, okay, so why it is happening? Because of concentration gradient. What is concentration gradient? Because of a higher gradient on one side and lower gradient on the other. We know that for an N-type semiconductor, their holes are the minority charge carriers, and for a P-type semiconductor, the holes are the majority charge carriers. So because of a difference in the concentration of these charge carriers, we have a concentration gradient. Fine. Similarly, so let me read this again. So similarly, when a hole diffuses from P to N due to the concentration gradient, it leaves behind an ionized acceptor negative charge, which is immobile. Okay, so quite evident. So basically, what is a positive charge? It is called as an ionized donor. What is a negative charge? It is an ionized acceptor. Okay, which is immobile. Again, it is immobile. Okay, so both the things are immobile only. Fine, let's read forward. So as the holes continue to diffuse, so we are trying to, the holes are continuing diffusing, it is diffusing. So it will lead to a layer of negative charge or negative space charge region. So as you can see on the P side, you can observe a negative charge happening here. Okay, on the P side of the junction is developed. Now read this last line very clearly. Okay, so this space charge region, this space charge, why it is written as charge? Because these are having positive and negative value or charges, therefore it is called as space charge region on either side of the junction. So this side also we are having a region, this side also we are having a region, is known as the depletion region. Okay, so this area is called as, so let me make it much more clearly. So this area is nothing but your depletion region. Okay, as the electrons and holes taking part in the initial movement across the junction depleted the region of its free charges. Okay, so here there is no free charges available now. These all are nothing but caused due to initial diffusion of charges being happened due to the concentration gradient happening. Okay, so let us read this line again. So this space charge region on either side of the junction together known as depletion region, as the electrons and the holes taking part in the initial movement across the junction depleted the region of its free charges. Fine. So it depleted region of its free charges, and therefore this is called as your depletion region. Let us understand more about this PN junction here. So till now what we understood in the previous slide, what we understood was, okay, so electrons were being diffused. As you can see, electron diffusion is happening in this process here. Similarly, holes are being diffused in this process here. Okay. Now let us look at drift. So there is something called as drift also. So you can see clearly that negative electrons are present here and positive are present here. right. So, a drift is happening of electrons toward this direction and a drift of holes is presenting toward this direction. There is nothing but your concept of diffusion and drift. Fine. So, that being said, let us move on forward. So, the thickness of the depletion region is of the order of 1/10 of a micrometer. So, what is the thickness? Thickness is of the order of 1/10 of a micrometer. So, basically this is nothing but 0.1 into 10 to the power minus 6 meter, or we can say this is nothing but 10 to the power minus 7 meter. We can understand what is the how narrow is this thickness of a depletion region. Okay, so this basically is the depletion region here. Okay, fine. So thickness, we understood the order of this thickness of the depletion region also. Next line says that due to the positive space charge region on the n side of the junction. So what is this region being talked about? This is the region being talked about. Okay, so let us look at this region here. So due to the positive space charge region on the n side of the junction, this is the n side of the junction, okay, and the negative space charge region on the p side of the junction, okay, and similarly this is the negative space charged on the p side of the region, p side of the junction, and electric field directed from positive charge towards the negative charge develops. Quite evident, we always know that there will be electric field developed if there is a generation of a positive and a negative charge far from each other. Therefore, what we can say that there is an electric field developed. This electric field is developed due to the concentration gradient happening. This concentration gradient led to the diffusion, and due to this diffusion a depletion region was created, and in this depletion region an electric field is set. Therefore, an electric field directed from positive charge towards the negative charge is developed. Fine. Due to this field, an electron on the p side of the junction, let us understand this clearly, an electron on the p side of the junction, so there is an electron on the p side of the junction moves to n side, and a hole on the n side of the junction moves to p side, quite clearly. The motion of charge carriers due to the electron field is called as drift. So that was the only last line which I tried to explain using this drift concept here also. So basically the passage which is movement, that is the movement of electrons and holes in the depletion region, is called as basically a drift, and the electron or the hole movement which is caused due to the concentration gradient is called as your diffusion. Fine. So we understood the diffusion also, we understood the drift also. Thus a drift current. So what is drift current again? So what is current basically? Current is basically the movement of charges due to per unit time. So if it's a movement of charge happening, let's say from point A to point B, then we can say that okay, current is happening. Okay, and now because this current is due to drift, so that's why the name has appeared as drift current. Okay, which is opposite in direction to the diffusion current starts. So okay, so this line is very important, that as you can see clearly that electron diffusion is in this direction, but the electron drift is in this direction. Similarly, hole diffusion is in this direction, and hole drift is in this direction. Okay, so that is how you can understand that always the concentration, any concentration you take, either electron or hole, the diffusion current will always be in the opposite direction to that of the drift. Okay. So that being said, let us look at this at a later stage. Let us first revise and then close this lecture. We will understand that in the next concept. Okay. So things which are required here is, first of all, you should understand bias. Okay. So in the last lecture also I put a forward about this concept here. So please remember what is bias basically. Bias is nothing but an external applied voltage. First thing to understand. Second thing you need to understand here is that where it is written, so concentration gradient. Okay, so concentration gradient, so just understand from here only. So everything which is happening, a PN junction is being formed due to the passage or due to the concentration gradient happening. Why is there a concentration gradient? There is a concentration gradient because on the N side there is a majority charge carriers of electrons, on the P side there is majority charge carriers of holes. If there are majority charge carriers happening, then there is a 100% certainty that there is a minority charge carrier happening also. Therefore, N type will have a holes as the minority charge carriers, and a p type will have a minority charge carriers as electrons. So therefore, because of this difference in the concentration of electrons and holes on both these sides, there is a gradient happening, and because of this gradient we lead to the formation of two different processes happening in this complete p-n junction. The first was diffusion, which was due to the concentration gradient, which led to a depletion region, and because of this depletion region being formed, there was an electric field being generated, and due to this electric field being generated, the electrons were being passed upon again and holes were being passed upon again, and this current produced was nothing but your drift current. Okay. So that being said, let us conclude this lecture here, and then in the next concept we will understand concepts such as barrier potential, then forward bias, reverse bias, etc. Okay. So let us stop it here only. So thank you so much.